Okay, so in this video we're going to cover inheritance. I've made a person class, and we'll use this as the superclass. All we have in here, all the information it's going to collect, all its inherit information is just going to be its name for now. We've made two other classes, one called adult, one called child, which we're going to extend these. So how to say this so this makes sense? If you think about it in the real world, you inherit certain things from your parents. That's why we're using this adult-child kind of hierarchy. We could have named it parent. Maybe that'd be a little clearer. We'll do it that way. And because you inherit certain things from your parents, you didn't have to create them. You didn't have to make them up. They just you get them automatically. And that's how inheritance works in programming. So with this parent class, we'll extend it. And it extends from person. Now we get this little error here saying you got to add the end constructor. The reason being is in the parent class of person, or the superclass person, we only had one piece of information in the constructor, and that was to set its name. Here we can do that. Now we can extend this, and this is where inheritance is really powerful. I don't like how congested those are getting. And then we'll make it setters and getters as well. Okay, so the idea here is when a superclass is created, you generally want to define a very generic class of the type. And you want to try to include as much information that all the subclasses of that are probably going to have naturally. So if we're looking at the example of parents, parents have names. They're also people. So we kind of go to the superclass of people. And what do people have? People have names. They have ages. They have a whole bunch of information. Now we're not going to get into defining it all here. We're just going to keep things a couple small pieces just to kind of illustrate this relationship of inheritance and how it all works. So we'll save that. That's the parent class, and then we'll go to child. And that's the wrong one. And child, instead of extending directly from the person, we're going to extend from parent. Notice it doesn't say this dot set age. It just says super dot set name, or super set name, super set age. Now the idea here is that by inheriting certain things, you can extend it. So let's go back up to the person class, and let's give them another variable here. We'll call it race. And we'll make setters and getters for that. Now, even though in the constructor here of this child, we don't have race defined as one of the parameters, because it's extended from parent and parent is extended from person, it has access to it. So we can actually, we can extend it. We inherited the methods from the top class, and we can extend these lower subclasses and enhance them, or rather expand them out and add more information that they didn't necessarily have. Now, we could here do and make it local to this, which would be fine. There'd be nothing wrong with that. But if we look in the person class, it already has a race method. So in the child class, we won't need to do that. That's why it's one good idea to look at all your superclasses to see what is being inherited down through all the classes. Here we could do Now notice that the error went away. What we're essentially doing is calling the method in this constructor from the superclass, if that makes sense. Let's use a visual here. So we essentially have a superclass which has a name, and we define, different things. We define its name, race, age, things like that. Because we're defining them in that class, and when we extend a subclass of superclass, it automatically gets a copy of all this information passed to it. It essentially inherits whatever was created in the superclass and is automatically a copy pushed down, or rather it has access to the things that were in the superclass. What you won't see is the code for that automatically defined. It's hidden, but because it's extending a certain class, in this case it's extending person, it automatically inherits all that information from the person class. So this is where you have a very powerful idea. You can create a very general superclass, and then from that, for example, in this current project you guys might be working on, or one of the ones where you're creating items, and then from there you make subclasses of items like power-ups, or if you're making a game, for example, you have an item class, and you try to define that as well as you can, has all the pertinent information to an item. Then you create these subclasses of like weapons and power-ups and whatever else, food, and those sub-items, those subclasses will actually share the same kind of information. They'll all have names, they'll all have kind of the same attributes, maybe a weight, maybe a slot that it takes up in the game, things like that. And because of that, it's powerful because you can take then the subclasses, you inherit automatically all the stuff from the parent class, and then you can expand it and add new features that the parent class doesn't have to have, but the subclass can have. For example, like if it was an item, you wouldn't necessarily implement ammo container in an item for the superclass of item, but if you had a gun of type item, well, that you would need a way to hold ammo. So now you're extending it. You have maybe an array or something to hold the different types of ammo. That's an example of extending a subclass of a parent class where it's becoming larger and not necessarily better, but just different of the parent class. Another example would be, let's say you had a calculate class, a parent class. Subclasses of that could be calculate the value of pi, and then you would implement fully the calculations to come to that value. It could be calculate just like addition or multiplication. You could have subclasses of this calculate class where they're working on things differently, but they all kind of inherit the same things from the parent class. For now, that should be it. You kind of get an idea of it. There's a hierarchy from a top class, how you extend it, how you make it in relation to or a subclass of that parent class is you simply include this extends and then the class name. If we look in the parent class, notice it's extending person. And this get age, set age, here in this example, we extended it or we expanded it beyond what the person class has. For example, person doesn't necessarily have an age. Maybe a better name from person would be being. And a being would have a name. It might not necessarily have an age. I guess it would because it would be alive, but bad example. So to keep things simple, and kind of to summary, you're essentially just extending or taking copies of everything in the parent class. You're getting access to all that same stuff. You don't have to redefine it all because it was already defined in the main class. And now you can focus on making this subclass more specialized. And that's probably a good way to think about it. You want your parent class to be as general as it can be and include as much information relevant to that thing. And then the subclasses, their job or their responsibility is to specialize and get very specific where the differences wouldn't just be general. And they would be different from themselves. So if you're extending, for example, an item back to the game example, when you're specializing, you would have a knife, which is very different than, let's say, a gun, which is very different than, let's say, food. There's characteristics just even in those ideas that are very specific to the thing, yet they have some information that's all relevant or all the same, or they all share a commonality of qualities that would be defined in the parent class. Is a bad idea using child and parent here, I think, because it's a little confusing. We use person as the parent class. And then we have parent, which I think is probably better to rename that adult. Because you have an adult and a child, and they share something in common. They might not be related, we don't know, but they all are part of the person class, which is a little more, I think, easier to understand, a little less confusing. So there you go. That's kind of the quick, simple rundown of all this lovely code and this idea of inheritance and extending a parent class and creating a subclass and things like that. One other key thing is in the example of here where we have a person class, when you're writing code, you may not need to define, you may not be writing or creating a person object. So it'd probably be a good idea to make it abstract. The reason being is the person class will never be instantiated. You'll never have an object of that. And it's then the job of all the subclasses to fully define the methods that were created in the parent class. Maybe that's getting into a little too much. So for now, just focus on, you have this idea of a parent class or a superclass, and then from there extending this superclass to all the subclasses where the parent class is general and the subclasses are specific. They share the same information as the parent, but they have a little more speciality, or they're a little more focused on a specific task.